Hello students, myself Aparajita Kumari Sinha. I am a biology teacher. Today we are going to learn a very important chapter of biology, chapter number 9, biomolecules. In the biomolecules, I am going to taught you a very important topic, that is nucleic acid. So let's start the topic. So first, at the very first, we should know what is nucleic acid. Nucleic acid, it is made up of two words, nucleic and acid. Then what is the meaning of nucleic and what is the meaning of acid? So nucleic means inside nucleus. Acid means acidic compounds. So when we are joining these two words, we are getting the definition of nucleic acid. The definition says inside nucleus acidic compounds are found. So inside nucleus acidic compounds are found, and those acidic compounds are called nucleic acid. So nucleic acid inside the nucleus exists in two forms, DNA and RNA. So inside the nucleus it exists in a two form, DNA and RNA. Nucleic acid belongs to macromolecule group. At the very first of the chapter, we divided all the biomolecules into two categories. First one is a micromolecule, second one is a macromolecule. So nucleic acid belongs to macromolecule. So if it is macromolecule, that means it has monomer. That means it is a long chain of monomer. The monomer used here, that is a nucleotide. So nucleotide is a monomer to make nucleic acid. So first of all, we are going to learn what is a nucleotide. If we learn what is nucleotide, then we can understand what is a DNA and RNA, and then we can understand what is a nucleic acid. So let's start. What is nucleotide? Nucleotide, it is made up of three things. First one is sugar. Second one is phosphate ion, or we can write it as phosphoric acid. And third one is nitrogenous bases. So nucleic acid is called acidic compound. Why it is acidic? It is acidic due to presence of these phosphoric acid or phosphate ions. So now start with one component of nucleotide. So first component, that is sugar. Okay, so here to make nucleotide, the sugar is used. That sugar is ribose sugar. Ribose sugar is a monosaccharide. As we all know, we already studied in a previous topic. Ribose sugar is a monosaccharide, and these ribose sugar contain 5 carbon. These ribose sugar contain 5 carbon. So what will be the formula for the ribose sugar? This will be C5H10O5. And the ribose sugar that we are going to use here, that is a beta ribose sugar. So now now we are going to learn the structure of ribose sugar. So which ribose sugar? That is beta ribose sugar. So start with the structure. So structure of beta ribose sugar. Beta ribose sugar, we represent it in a cyclic form. So this cyclic form structure formed due to the bonding between C1 carbon and C4 carbon of the ribose sugar. So now we are going to put every carbon in this structure. So this one is a carbon number 1. Here we can write carbon number 2. Here we can write carbon number 3. Where we are going to write carbon number 5. So we write carbon number 5 out of the ring and it is connected with carbon number 4. So here it is carbon number 5, CH2OH. As we know, the monosaccharides are polyhydroxy. Polyhydroxy means a compound having more than one hydroxyl group. So monosaccharides are also having more than one hydroxyl group. So in this compound we are going to put hydroxyl group. At the C1 we are writing OH at the upper position and H at the down position. Why we are writing like this? Because this sugar is beta ribose sugar. Now come to the at C2. C2 we are putting OH at the down and H inside the ring. At the C3 we are putting OH at the down and H inside the ring. And now at the C4 we are just putting H. Okay. So now count the carbon number. This is the carbon number 1, carbon number 2, carbon number 3, carbon number 4 and carbon number 5. So ribose sugar having 5 carbons. It is a 5 carbon compound. So this structure belongs to ribose sugar. But in the nucleic acid, two types of ribose sugar are formed. One is called deoxy ribose sugar and second one is called ribose sugar. So why we are calling it is deoxyribose sugar and second one as a ribose sugar? The two words are similar here. Ribose sugar. Here also we are writing ribose sugar. Then what is the meaning of this deoxy? As we know, whenever we use this word de, that is the meaning of removal. And when we use this word oxy, that means removal of oxygen. So deoxyribose sugar is formed due to the removal of oxygen from ribose sugar. So in this ribose sugar, from which carbon the oxygen group is going to be removed. Now we are going to learn the structure of deoxyribose sugar. So first of all, we are going to make ring structure. So we are going to put carbons. So here is a carbon number 1, here is a carbon number 2, here is a carbon number 3, here is a carbon number 4 and here it is carbon number 5, that is CH2OH. Okay, so at the carbon number 1, the OH group place similar to the ribose sugar, OH group at the up and hydrogen group at the down. In this carbon number 2, in a deoxyribose sugar, at the carbon number 2, only hydrogen is present. There is an absence of oxygen. As you can see in the figure, in the ribose sugar, at the second carbon, OH group is present. But in a deoxyribose sugar, at the second carbon, only hydrogen is present. The rest part is similar to the ribose sugar. The rest part of deoxyribose deoxyribose sugar is similar to the ribose sugar. So here we are going to put OH group, here we are going to put H, and here we are putting H. So this structure is called deoxyribose sugar. Okay, so this structure is called deoxyribose sugar. So in DNA, we are going to the form deoxyribose sugar. If we expand the term DNA, it says D for deoxyribose sugar, N for nucleic, or A for acid. So DNA means deoxyribose sugar, deoxynucleic acid. So that means DNA contains deoxyribose sugar, but the RNA, it says RNA, that means ribonucleic acid. It says ribose, the RNA contains ribose sugar. That's why the name is called as ribose nucleic acid, ribonucleic acid. So RNA contains ribose sugar, but DNA contains deoxyribose sugar. Now come to the second component of nucleotide, that is phosphate ion or phosphoric acid. Okay, if we see the phosphoric acid structure, it is nothing. The phosphorus in the center, and this phosphorus is bounded with the one oxygen and 3 hydroxyl group. If we are going to see the structure of phosphate ion, it is a nothing. It is just in a center, it is a phosphate. This phosphate is bonded with oxygen with the double bonding, and these OH groups just remove hydrogen from them and they become O minus, O minus, O minus. So we have written PO4 3 minus, that is a phosphate group, and here it is written PH3 and O 1 2 3 4. So PH3PO4, that is a phosphoric acid. Now come to the third component of nucleotide, that is nitrogenous bases. The nitrogenous bases is further divided into 2 categories. One is called purines, another one is called pyrimidines. One is called purines, another one is called pyrimidines. In a purine, 2 types of nitrogenous bases are found. One is adenine, and second one is guanine. Okay, come to the pyrimidine. It contains 3 types of nitrogenous bases. One is thiamine, second one is uracil, and third one is cytosine. Okay, so this adenine, it can be represented as A. This guanine, it can be represented as G, because the first letter of this word starts with the G, so it will represent as a G. Here, the first letter of this word is using to represent adenine. Like that, we are going to giving the representation or denotation term. So thiamine is represented as T, uracil is represented as U, cytosine is represented as C. So now purines contains 2 nitrogenous bases, A and G. Pyrimidines contains 3 nitrogenous bases, P, U, C. So how we are going to remember which is a purine and which is a pyrimidine? It is a very we can say easy method to remember. See here, adenine is having 9 at the end And guanine is also having same one, 9 at the end. So 9, 9 are grouping together. That's why adenine and guanine are always present in a purine. Okay? And apart from these, all three, they are going to present in a pyrimidines. To remembering the pyrimidines, we can also use some word like cut. Cut. You can see when we go from down to the up, this word will become C for the cytosine, C, U for the uracil, U, T for the thymine, T. So C-U-T, cut. So like cut, you can remember if we say cut, that means it is a pyrimidines, and if we say 9, it means it is a purine. Okay. Now come to the purines. What is purine contain and what pyrimidine? Pyrimidine, it is a made up of what? And purines, it is a made up of what? So purines contains heterogeneous cyclic double ring compound. So what is the meaning of heterogeneous? Heterogeneous means a carbon compound not only made up of carbon atom, it also made up of some other element. So we are going to draw this structure of the purines, then we can understand what is purine. So purine contains double ring structure. So first of all, we are going to make these two rings. This is a first ring and this one is a second ring. So first ring and second ring. In the first ring, at this position, not carbon is present. Instead of carbon, the atom is present, that is nitrogen. Here also nitrogen is present. Here also nitrogen is present. Here also nitrogen is present. And remaining corners contains carbon. So these type of the cyclic compounds called heterogeneous cyclic compound. And it contains two rings. This is a first ring which has 6 corners, and this one is a second ring which have 5 corners. So this is called heterogeneous cyclic compound. So this is the structure of purine. Now come to what is the structure of pyrimidines. Pyrimidines contains only one heterogeneous single ring structure. Okay, so it is also made up of heterogeneous ring, but the ring number is only 1. So made up of heterogeneous cyclic ring, and the ring number is only 1. That means we are going to make one hexagonal ring, and this ring represent pyrimidine. So in this ring, here also nitrogen is present, and at this position here also nitrogen is present. So now just compare this pyrimidine structure with the purine structure. If you just cut this ring, we are going to get pyrimidine. Listen carefully again. If we cut this ring from the purines, we are going to form pyrimidine. Okay? So pyrimidine, the name is big but the structure is small. Purines, the name is small but the structure is big. Okay? So in this way, you are going to remember, you are going to keep this in your mind. What is purine? How many ring structure it brings? And what is pyrimidine? How much ring structure it brings? So purine, it is a small word but the structure is bigger. That means it is having two ring structure. Pyrimidine, the name is big, but it's have very small structure. That means it have only one ring structure. We can also say if we cut purine, we are going to get pyrimidine. Okay, so if we have cut one ring of the purine, we are going to get pyrimidine. So now for today, it is the end of the topic. Thank you.